Welcome to EDU World Space.
In the given question, we have to find out the velocity of this rod which is coming down vertically and will enter into this tank of liquid, and its velocity when it finally reaches the bottommost, the lowermost part of the water being completely immersed. So in this case, we'll see some important values. So the specific gravity, or we can also call it as relative density, has been given to us as 2. The area is this is the area of cross section of the rod. We have been given the density of the liquid as rho. So this is for the liquid, or it can be for water as well if this is water. And also we can take sigma to differentiate. We can take sigma as the density of the rod. Now, firstly, here we have to calculate the velocity when the lower end of this rod hits the water surface. This lower end, which has been highlighted in blue, hits the water surface. For that, we'll simply use the formula root 2gh, but in this case our h will be different. So let's take v dash as that velocity. So it will become root 2g, and this will become h minus L by 2. So h minus L by 2, because the center of mass is located over here, so this is at L by 2 distance. So we'll subtract that extra distance. So this is the velocity when the lowermost part of the rod touches the water surface. Now, assuming that this entire rod has reached up till here, the surface, when further it goes into the water, let's assume it has immersed to a distance of x, and still there is some part yet to be immersed. In that case, the resultant force, there will be some force acting. So in that case, the resultant force will be equal to LA, which is the length of the rod into area, into sigma g plus LA. Here L will be x because x distance is immersed, into sigma into rho g. It's rho here because x part is in rho liquid, and this one is, which is the entire rod's density, which is sigma. Moving on to the next part, from this we can calculate the acceleration. So it will be LA sigma g plus XA rho g upon, we won't write m because we have to write everything in terms of density, area and length. So it will become LA sigma. When using this relation of RD, which is relative density, we can easily eliminate these two variables in our equation, which is rho and sigma, and we can get the final acceleration to be g by 2L into 2L plus x. So this will be our acceleration in this case. We all know that acceleration can be written as v dv by dx. Now this will be equal to, we are just replacing this a with v dv by dx into 2L plus x. Now we can integrate this as we have two variables. We can integrate it on both the sides by separating the variable separable method to dx. So this one integration will take place over here and the other one will take place over here. So let's say it's from v dash, because v dash is when it has already hit, up till v, any point after it has hit, and this will be from 0 to completely immersed, which is L. On further simplification, we will get v square minus v dash square upon 2 will be equal to g by 2L into 2L square plus L square by 2. So this can be further written as, we can find out the value of v from here. So v will be equal to root 2g small h plus g L by 2. Now moving on to the next part, when the rod is completely immersed, we can say that the resultant force in that case will be equal to g by 2, using all the relations that we have found out above. And now we can simply use, the acceleration, not the resultant force, will be g by 2. And using simple equation of motions, we can find out the velocity that will be of the rod at the end when it reaches the bottom of the tank. So in that case, we can simply use v square is equal to u square plus 2as. So here v square is the final velocity that we have to find out according to our given question. Let's take it as v double dash square, and this one will be our v square, which we found out over here. So it's v square plus 2, our a is g by 2, which we got over here, into s. S is the distance which has been covered, which is LH minus L. H is the entire height of the tank, and L is the rod's length. Now using this, we can simply say that v double dash is equal to root g h plus 2 small h, which we have taken, plus g L by 2. This is our answer for the question. So I hope you all have understood. Thank you so much.